Using and slightly abusing APCu in high-load concurrent environments is what we are going to speak about now. Before that, I would like to say a few things. Дорогие друзья, я очень рад быть сегодня здесь, в Москве. Я хочу поблагодарить организаторам за то, что приняли мою презентацию. Я хочу поблагодарить также компанию Altenar, которая сделала мой визит возможным. And now that I used up about 82% of the words I know in Russian, and the rest are not work safe, unfortunately, I will have to continue in English. It's nice to be here. A lot of smart people make me feel uncomfortable, but it's fine. I'm going to tell you a story about APCu and myself. But before that, let's see what exactly is APCu. APCu is a PHP/Peer extension. Usually it's installed via Peer. It's an in-memory cache. This means that it's always inside your memory. This is the previous executable file cache for PHP. It was replaced by Zencache, opcache. And it remains inside PHP as a general object cache. So this has a few benefits, a few important benefits that make APCu quite a good candidate to use for caching environments. First of all, it's fast. It's very fast. It's as fast as having almost as fast as having the objects inside your PHP file declared. It's faster than any database. Because even if you have the best installation of a database, highly tuned, huge amounts of memory, everything staying in memory and being sent back to you, still you have to go through the network, and still when you are doing writes, you have to write to the disk. It's faster than all other caches. Memcache, Redis, whatever, because you don't have to go through the network. It's a native of PHP, so essentially it runs in the same memory and process space as your PHP executable, be it a SAPI module or FastCGI or what have you, it's inside there. And it stores PHP objects and primitives with minimal overhead. See that asterisk there? Remember it. There are some shortcomings. Whenever you do something in life, you give something to get something back. And these shortcomings are the documentation is not the best, slightly inaccurate in places, as we are going to see. It is PHP local, which means that it runs in your process. That's good, as we said, but that's also bad. Nobody knows anything that happens inside APCu. And of course, there are no interoperations with other languages or whatever. Takes memory from the node that runs your code. So your server memory is being sucked out of memory because this goes to APCu. Sometimes you may say use X amount of megabytes, and depending on your data and how things are configured, it will not use this amount of megabytes. So you will have less available cache than you think that you have. We will discuss this later. And finally, there is no segmentation mechanism in the sense that it's a one block of cache. So you cannot treat it as different, let's call it caches, different databases for different parts of your system. All the keys are in the same space. If you call flush, for example, everything is gone. So these are minor nuisances. APCu is an excellent cache when you're doing any sort of normal project, it's a very good cache to use, very powerful, and very, very fast. Unless you want to use it in concurrent environments, like Kubernetes, auto-scaling VMs, or anything like that. That creates the APCu concurrency problem. This means that essentially it is very difficult to do it. Classic caches use sharding, so especially they split your data into different pieces, and each caching node has a different piece. Or for smaller projects, you get one big node that handles all caching for your whole thing. But in Kubernetes or auto-scaling VMs, we have many nodes handling our traffic. We have a lot of pods in Kubernetes, and we don't know how many they are. It's not that we don't know really how many they are, what's the maximum, what's the minimum, whatever, but in theory, at any given moment, it could be any number between our minimum and maximum, and we don't know what those nodes are, where they are, what's they're called, they're whatever, because these are all auto-scaling. So this combined with the fact that there is no inter-node communication, because APCu is local to the node that you're running. It doesn't matter that other PHP executables have their own caches. They don't communicate between them. This creates the problem that when you save, for example, a key in the cache, nobody else knows about it. It's saved locally, and that's it. Every other node is oblivious to this change. Even if you put it in the database, you still have a big problem. Why? Because unless this key happens to expire in the other caches, it will not be refreshed. So you have in the database a new value, and in all the other, and your node, and all the other nodes have an older value. So that's seemingly very difficult or even impossible to overcome. And somebody will ask, is APCu unusable in such environments? No, it's not. It's not. What if we have data that we don't need to write? What if we have data which are no modification needed, or they are so rarely modified that we can do some other tricks and still use them with APCu? I'm going to tell you a story now. So, some time ago, in a country far, far away called Malta, I was hired at Altenar, and now I work there as a software architect. Initially, I was a senior software engineer because there was a probation period, and what I say here was during that probation period. How did I manage to survive? It's a good story. We'll see about it. So I was hired only 2 weeks in the company, and I was asked, can we somehow, dear Mr. Architect, minimize the amount of traffic that we have in the network and the amount of queries we are doing to the database for this data, which we use again and again, and it's inefficient, it's wasteful? This question, by the way, was asked by the chief architect. Okay, here is my time to shine. Classic local caching issue, can resolve it very easily. So I said, wow, we need to have a local cache, of course. We already have Redis, we want to cut down on the network. Fine, I exclaimed, I can do it. We need to install memcached locally on every pod. Then the chief of backend developer, Grigori, said, use the APCu. It is PHP native, and it will be faster. Now that I think about it, I think it was a setup. So the chief architect concurred, yeah, let's do that. And said, fine, what a fool. I had hoped that with a little bit of configuration, I could make memcache keep data local and just propagate the changes to all other nodes. Multi-master solution, very nice. It doesn't do it. Even Redis cannot actually do that. So, lesson number 1, don't flap your stupid mouth without thinking first. Especially about caches. Okay? Okay. So, back to the drawing board. Let's see what can we do to dig ourselves, myself, out of this hole. We need to think about data. We need to find data which are not changing, or data that I can control when they change. And we should never bother with data that are rarely used, because there's no reason to do that, just waste time. Let's think about it. User data. No, user data can be changed at any time by the user, and we have this whole propagation problem again. Games data, by the way, Altenar is a company that specializes in software about betting and casinos. So we have games, iGames, gambling. This is a good candidate. Why? These are provided by third parties. We don't make the games, we just interface them to players. They don't change. And whenever there is a change in a game, a new line is added, and the preview stays there for compatibility reasons. That's a good candidate. Configurations. Could we use configuration like that? Depending on your system, yes, you can use configurations, especially for systems that configuration change means redeployment. You can do this all day long, easily. Limit data. What's limit data? For example, a player wants to limit the amount of money he can gamble in a day or in a month. Can we use that? No. The player, unfortunately, can go and change these things, impose self-limits or whatever. There are regulatory requirements to exclude and limit players. This can come at any time. We don't have control over it. Can't use it. Templates for emails. Again, if you are requiring templates to be deployed every time when you change them, or if you can control when you have the changes of the email templates. For example, if it's okay for you to wait for a day, let's say, until the new templates take effect, yes, you can use them. User consents history. These are data which are rarely used, but nobody takes a look at. Still, they can change whenever. A user can withdraw his consent. He can do a new consent for a new version whenever, so we don't have control over these things. Hierarchical user data, by no means, no, these are changing all the time. It's a complex structure that you cannot control, so no. So, is there a way that we can tell if some data are a good candidate? Yes, there are 4 questions which we are going to go through. And if any of the following questions is not what we expect, then this data is not good for you. So, first question, data handling is resource intensive in databases or network traffic? This should be true. If it's not, don't need to bother with caching. Okay, it's not worth the effort. Is the data immutable or changes with a frequency significantly lower than the cache eviction cycle? Can we live with displaying slightly older data at some points? Or can we control when the eviction happens and the repopulation goes on? If something of this is true, then we can continue. If not, that's not your data. Is the data size small enough to fit in the memory that we dedicate to APCu? Obviously, this should be true. And finally, does the non-existence of data signify something? For example, user access tokens, right? When you go to your store, your cache, whatever, and you check for the existence of a user's access token, if you don't find it there, unfortunately, there are two different things that might be happening. The first thing is that this guy had logged in, the cache expired for his token, you go to the database, you find the token. The other case is that this guy has never logged in and you don't have a token anywhere. So, unfortunately, if the non-existence of data signifies something to you, in this case, non-existence of user token means that the token is not, the user is not logged in, you cannot use this data. Because to be sure, you have to go to the database, you have to check for this token, so you just negated the use of the cache. Okay, after figuring all of these things out, I got a data set to use with the APCu. It's the games data. These are metadata about casino games, such as IDs, thumbnail locations, game types, game categories, who's the publisher, statistics, and whatnot. Statistics not that change, like statistics that we get from the games provider, for example, the return to player is 97% or something like that. So these are very good data. These change once per day. I can control the cache eviction and the repopulation of the cache. We're fine. Yep, as we said, these are immutable, whatever. And also they were slightly small size, so it's fine. We are reading these things from the database every time, and we use these things continuously because every time a player launches a game or makes a game round, so he goes to the virtual slot machine and pulls the handle, we need to read this data. It's a perfect scenario. And then I had a brilliant idea. Why don't we use the cache as a store? What an idiot. I must be genius, right? No, what an idiot. So, let's talk about caches and stores. A cache may contain the data, but maybe not. A store must contain the data. What if data is not in cache? You go to the database, you find your data, everything's fine. What if data is not in the store? Data is nowhere else, your system crashes. Store must be durable, obviously. A cache, no. In theory, a cache can fail. The store cannot. If your cache fails and you are worth your salt, your system will keep working, painfully slow, okay, but it will not die. If you lose the store, not much you can do there. So, that was a completely stupid decision strategically, because in order to save a few requests to the database in the span of a day, I introduced a single point of failure. Cache dies because I'm using it as a store, now the system dies. Thank God, and that's why I'm still here. Operationally, it was a good decision because if APCu fails, the cache, PHP has failed also. It's the same thing. The system is already dead, nobody will blame me. Good. Lesson number 2. The situation dictates the solution, not any best practices, not any conventional wisdom. Don't copy-paste, put your brain to think, and you will find the optimal solution. I write the code, I test the code, it works, we deploy the code. Success. We see a reduction of about 1,500 requests per second to the databases. My first project, I'm kicking butt, I'm very good. I live the dream. Only to be awakened by the angry yells of Nikolai, the team leader responsible for deployments, resources, etc., etc. He's screaming in my ear, apparently, we are using a lot of CPU. And when I say a lot, I mean a lot. 9 times more. The numbers are, of course, not correct. I'm not at liberty to disclose our exact network stuff and infrastructure stuff, but the analogies are correct, the proportions are correct. So if we had 1 active pod and 4 pods that were standby, we ended up with 9 active pods and 12 pods on standby. That's 9 times more. Let's discuss APCu internal storage format. As we said, APCu stores everything as serialized PHP objects, that is, text. Serialization is automated. You put things in the cache, serialization happens from the background, text is put in memory, you draw things from the cache, deserialization happens in the background, you get nice objects. Fine. Fine when you store, fine when you retrieve data in small quantities. The idiot who's talking to you created an array that had tens of thousands of objects, and he was deserializing this for every request, which apparently is not a good idea. That's what spiked the CPU. Lesson number 3. It worked on staging is equivalent to it works on my computer, unless the data amounts and requests per second are equivalent and equally as diverse. Because of course I had tested this on staging, of course I had put a lot of data in it, but it was the same data again and again. And it somehow worked. If you have a small amount of data that you hit every time, you can hit them tens of thousands per second, it's fine. But what if the data is huge? What if you have to deserialize it every time? You basically sink your CPU. So, what do I need to do? I need to split the data from one huge array to smaller individual objects. But this creates an issue. Reloading the data is not easy anymore. Now you have to read the database and create a key for everything. And as we said, APCu doesn't have flushable segments. Now, if you want to flush the cache, you don't just kill one key. You have to kill all of them, all of these tens of thousands of keys. So, if I was going to use the flush command to empty the data, I no longer have a store. As we said, the idiot tried to make the database work as a store. So, I created code which appends prefixes on a per feature basis. So if you have different features that you want to store data for in the APCu, now I made code which automatically adds prefixes. For example, for our data, in this particular case, it would be game list underscore and key name that you created. Now you have to store all the keys that you create in another pre-known key for this segment. And to flush the keys for this feature, you have to iterate through this pre-known cache key and delete all the keys for this specific segment. Isn't that slow? Yes. It takes sometimes half to 1 to 2 milliseconds at worst case, usually half a millisecond. And no, it's an extraordinary event in the grand scheme of things, which happens once per day or even once per hour, doesn't matter what happens. It's a very small amount of time for one node. We can't tolerate this. So there will be one query, one request, which will delay by a slight amount of time when you're trying to do this at the same time. But remember, we are controlling when this is happening. So it's fine for us. Is it a pretty great solution? No, but it works. I write the code. I test that code. It works. We deploy the code. Success. We see normal CPU usage. Everything is going great. We had a small hiccup, but we fixed it. I'm living the dream, this time for real. Until I am awakened by Nikolai's angry yell in my ear. He is our team leader responsible for deployments, resources, etc. And he's screaming. Apparently, we are using a lot of database. What? Why? We are up 25% in latency. We were back to where we were before the cache thing as far as queries per second is concerned. And now we are even worse, using 50% more traffic between the pods and the database. I'm dead. Lesson number 4. The two most difficult things in computer science, software engineering, are naming variables, cache invalidation, and off-by-one errors. Remember that? It's a joke, it's true. That's a disaster. Smugly, the chief architect says, you are repopulating the cache continuously, you screwed up. He's correct. This is the only thing that could be happening. But how can this be happening? Could it be that the 16 megabytes of data, when cached in a few tens of thousands of different serialized objects, when we deserialize them, or sorry, when we split them into those different objects and put them in memory, could they be more than double? I had 32 megabytes of cache, right? I double the memory in APCu. I ask for a redeployment as fast as humanly possible. Nikolai obliges because his database is burning, basically. So nothing changes. Despite the fact that in the end, after we resolved everything, we found that they actually do go up to 34 megabytes. So if it was not that problem that we are going to solve momentarily, it would still not work because we would still have more memory required. Lesson number 5. Do a good job in calculating the actual memory usage and don't rely on ballpark figures. I will give you a formula that works, kind of works in a while, but have that in mind. Don't make any guesses, don't assume things, do actual proper measurement. So this behavior is a little bit crazy, right? We need to check the docs. This is a screenshot of the actual PHP docs. So SHM segments is how many memory segments you have when you're using memmap, which is basically what every modern Linux distribution uses. This doesn't count. You have only one segment. SHM size is basically the amount of memory that you dedicate to APCu. Supposedly we had enough. What's the problem? And then this thing, apc.endRes_hint. A hint about the number of distinct variables that might be stored. Set to 0 or omit if not sure. Right? So, as we said, the first one doesn't do much because now it's only one segment. The second one is something that you can always keep in your mind because it's not the maximum memory you can use. You will probably see smaller memory usage than the maximum at the point that evictions start happening. So you will see usage, let's say you have 32 megabytes, and somehow you will see 28, 29 megabytes used, and then you will start having evictions. Keep that in mind. And then the entry hints. So now that's a whole different story. A hint, from the dictionary this is something used to help someone prepare for a situation. So this should just pre-allocate some entries for the cache to be ready to accept a large influx of data. Right? Nope. So This cannot have an effect on performance because even if it's not exactly like this, the cache will eventually stabilize. You put a lot of things in it, you don't have entries, entries are being created, new memory is being allocated. At some point, you will reach an equilibrium, and surely the cache will catch up at some point, right? Nope. Wait. Do you mean that this is the hard limit of entries allowed? No, because we saw more keys in the cache than the entries. This numbers function is incomprehensible if you just read the docs. Unless you look at the source code. No, the entries do not expand. They are a set number, that's it. And there is not a one-to-one relationship between entries and keys. You can have more keys than the actual entries that you get. This is where the memory is being allocated. Basically, the headers and the cache entries. That's C code, don't worry, it doesn't bite. I mean, it does bite, but it's fine. It's in the monitor for now, we're safe. So lesson number 6, set entries hint to twice the number of keys that you expect, and calculate the needed memory as the entries hint multiplied by Q, where Q is the size of the largest serialized object you expect to be storing. If you think that this is very vague, and if you think that this is very wasteful, you are correct on both counts, but unfortunately you don't have something more specific. I would say that you need to start from something like this, check how things are working and what's happening, and adjust accordingly if you need to. And for us, it was the number of keys before eviction start was 2.5 times the number of entries hint. Why? God knows. It is obviously dependent on the size of the average size of your data, for sure, and that's a ballpark figure which may or may not work for you. You can do something that we eventually did. We set it to something crazy, like 250,000 entries, and now this works fine. So the whole thing didn't crash. It can keep working normally, and we don't have any issues with how many keys we use. So finally, Nicola is calm. Sunshine all over the place. Minus 1,500 requests per second to the database. The latency reduction was in the order of 7%, 9% when we combined this with another set of data put to APCu. And this is the latency you see from the load balancer to the nodes. I'm not talking about the actual users, right? I'm talking about load balancer to pods. Significantly less bandwidth used between the nodes and the database, and CPU is up 3 to 7% depending on the load. When the load is high, CPU does need some extra time to decode and recode the things that it stores to APCu, so you see a slight increase of CPU load. Summary. Never, ever, ever underestimate caching. Might be simple, might look nice and easy. Put your brain to think, don't be like the idiot. You can do things differently than the norm, as long as you know what you're doing, and as long as you experiment a lot with actual data. Do not assume. Use the real thing, and you will be fine. Very useful to go through the source of the tools that you're using. I know it's C, I know it's scaring. You're all software engineers. You can read a language, PHP, you can read any language. You might have to search a few things, it's fine. You will understand what's happening much better, and you will be helped a lot. APCu, with all these things that we said, can be used in concurrent environments and can actually yield significant results. APCu can be abused as a store, But I would actually not recommend doing this because what you get back is not really that worth it. I did run a test where I was using the exact same thing without being used as a store. So I had normal cache with independent keys, which got evicted after some time. And I still saw significant advantages in the order of 8%. If you think about it, that's only 1% less than the full store solution. And this is in the realm of statistical error, so really it's not worth it. Your mileage may vary. This solution may offer you something significant, so always have it in mind. Just don't overdo it. That's it. Thank you very much. I am Ioannis Loukeris. I'm software architect at Aldernar. Please don't forget to vote me for president. Thank you.
Thank you very much. Ну что ж, друзья, вы можете задать вопросы. Лучше на английском, но если на русском, я переведу. Или постараюсь. Yes. Пожалуйста, вопрос во втором ряду.
Do you think this format serialization protobuffer flat buffer with don't using this classical serialization?
Sorry, if I understood correctly, you said if using protobuffers would be something better.
Protobuffer or flat buffer. Flat buffer, it's native transform. It's a memory. It's a very easy transform memory. It's not needed. It's real serialization. It's a put data.
Yes.
Yeah. Okay.
Yes. So if PHP at that point had a digital way of serializing stuff like protobuffers or the flat buffer that you offered, yes, things would have been much better. Even my first solution may have worked because for a modern day PC, copying 16 megabytes of memory from one place to the other is basically nothing, right? And if it was a little bit smart, that would be a pointer. No copying would be necessary anyway. I mean, maybe that could be done. I don't know. So yes, things would have been much, much faster.
By the way, Ioannis, you'll have to choose the best question.
Yes.
And we'll give a present. So
yes, sure.
All
right. So about the last question, as far as I remember, there is a custom serialization model for PHP that is actively used called igbinary. That changes the serialization format to the more efficient. That's binary, and it's easier to pack and unpack.
Yes. There is, unfortunately, APCu by default uses the old
cannot be changed
text thing. I think that you can actually change the serializer, to be honest with you. But at the time, I didn't know the existence of what you actually.
Okay. And the second question is about what was the initial state? You're comparing like the 9% of something?
Yes. So in the initial stage, we were just reading from the database, and the database was very optimized. It was all in memory.
No caching, right?
There was no caching, but essentially the database was so well optimized that it was acting like a cache because everything was inside memory for the database, and there was no reading from the disk happening. Essentially, just suck the data out of the memory, send it through the internet, I mean, the local network, and we were getting it in the PHP side of things.
All right.
Essentially, it was like having Redis.
Yep.
At some point, I ran a test with Redis, and it was more or less the same thing.
All right.
Only slightly faster, because obviously there is not the MySQL front-end decoder to decode the SQL queries and things like that.
Redis was the same thing as database or with the APCu?
Redis was faster, slightly faster, like 1% faster than the database. And APCu was 9% faster than the database and 8% faster than Redis.
All right, good. Thanks.
Excuse me. Second question: you using this Redis or Redis cluster or Redis sharding schemes? This critical question. Your points. It's very good in anything, but it's a little bit don't consistencies.
So for Redis, we used one managed instance by Google Cloud Engine.
Yeah. Thank you.
So that's what these results are based on. I don't know if I should have said that.
It's too late. So.
Uh-oh, HR is there. Hi.
Yeah. All right, I think that we've got...
There's another question.
One more
Hello.
question.
Hello.
You said, or maybe it was written on slide, if APCu fails, then PHP fails. What did you mean by that?
Given the fact that APCu is essentially in the same memory space as the actual PHP executable, if something goes very wrong with APCu, it probably will bring down the whole PHP executable that you have. The fast CGI will just die. This happened actually once while I was testing. I don't know why this happened. Unfortunately, I didn't manage to get a dump or something to see what happened there. But in my local machine, APCu, I was doing a lot of things. I don't know exactly what caused it. APCu did a segmentation fault, and then my fast CGI thing stopped working. I had to bring down the whole Docker container, restart it, and then it started working back. So most probably, I mean, is there a freak case where you could lose APCu and PHP keep working? Maybe yes. But I would expect, you know, as a precaution, that if you fail, if you have the APCu fail, PHP will not be functional anymore.
Yes, thank you. So APCu is PHP extension and probably...
Yes, it is an extension of PHP. APCu is a piece of PHP once you load the extension.
Okay, thank you. And I just would like to add that probably APCu is a good choice for to store application metrics for Prometheus, even if we flash everything.
So if I think that you are correct, if you design this thing in a clever fashion, I think you could do it, because you could aggregate this data from all the pods and get the end result in the end. If you try to store it like a number, so let me give you a very rough example. If you say I had 5 hits, right, and you have multiple concurrent pods running, in order to get the correct result, you have to sum all the hits from every pod. So if you have another small system that gets data from the cache and do this aggregation or whatever else is needed, yes, you could actually, I think you could do it. And it would help you tremendously, because you wouldn't have to go through the network to send something to, I don't know, any other metrics engine that you have.
Yes, thank you.
All right, so which question do you consider to be the best, the most interesting one?
I will give it to the last gentleman.
All right.
Because the metrics idea is a very good idea. I think it's usable.
All right. So he will get a present, and you will get a present as well.
Thank you.
So this is a PHP elephant, some accessories for sleeping, and a bag, and a lot of other stuff.
Thank you very much. Thank you. All right, that goes to my office.
Thank you.